Okay guys, we are starting our new unit today, and our new chapter. We're on chapter 5, so you should have your chapter 5 notes. And as you can see looking at the first page of chapter 5, we are moving into ratios and ratio boxes and tables and unit rates and all those fun things that you started out learning how to do last year. Hopefully you remember how to do those ratio boxes because we're going to still use them this year. But before we get into solving for ratios, we want to talk about and remind ourselves what a ratio actually is. That's why I put this part on your notes so that we can refresh ourselves. And I know you just did the vocabulary for a ratio, so you should be pretty good with this. A ratio is a comparison of two quantities, or two different things. Cats to dogs, pumpkins to squash, birds to trees, things like that. Comparing two separate things. What's different that we haven't really talked about and kind of new to us is the value of a ratio. What is that ratio really telling us getting down to? And we write the value of the ratio as a fraction, which is also the multiplicative relationship between the quantities in a ratio. So as a reminder, there are three different ways to write a ratio. And think back to last year when you talked about this. See if you can remind yourself what those three things were. Okay? It gives you a little hint here on our notes about what it could possibly be. So the first one, we have 2 snails to 6 fish. This is our word form. We can write ratios in word form using the keyword to. Okay, that's our comparison right there. The next example says we have half a cup of milk for every 1/4 cup of cream. That's also for every. It's still our word form. So there's one form right there. You can also write it here where it says algebra using what we call a colon. Okay? So if I wanted to write this snails to fish example ratio, I could do 2 to 6. Or if I wanted to write the milk to cups of cream, I have 1/2 cup of milk to 1/4 cup of cream. So those are two ways, but there's a third and final way that we don't need to forget because this ties back into the value of the ratio. So this is one way, this is two ways, and then our third way is the fraction. And remember, if I'm taking the time to write it down, you should be taking the time to write it down as well. So we can write it in fraction form. So if I wanted to take this 2 to 6 ratio and write it in the fraction form, whatever's first goes on top, whatever's second goes on the bottom. So 2 to 6 in word, 2 to 6 in colon, 2 to 6 as a fraction. I can also double up my fractions. I can do, if I was doing the cup milk to cream situation, I would have 1/2 over 1/4. So those are all the different ways. Those are the three different ways you can write your ratios. So anytime you actually see a fraction, you're actually talking about a ratio. And what two things are we comparing in a fraction, if you think about it? What does a fraction represent? Here's my fraction. And I know the top is my numerator, but what does the numerator represent? My part, that's right. And the denominator of the fraction represents my whole. So as a fraction is really representing a ratio of part to whole. Okay? Just some tidbits to remember. Alright, so let's start applying this information here. So example 1, you're making flubber, which is kind of like our slime that y'all make. I don't know if y'all ever saw the Flubber movie, but there's a movie about flubber as well. But flubber, these are the ingredients needed to make flubber. We've got cold water, hot water, glue, and borax. Okay, maybe you can take this home and try it yourself. But part A says, write the ratio of cold water to glue. So we're writing the ratio. We're going to write all three forms just to get that practice in. But you remember with a ratio, a big part to remember is that order matters. So whatever they tell you they want first, you have to put first. So if we look here in our example, they have cold water, then glue. So we want to come over here. Here's cold water. Here's glue. Okay? I want to first write that using word form. So I would do 3 halves to 2 cups. I could write it as a colon. 3 halves to 2. And I can write it as a fraction. 3 halves over 2. And those are the 3 different forms that I can use to write my ratio. Most of the time, they'll tell you which form you want, but sometimes they may not. So you need to be able to recognize it in all 3 forms. All right, part B is the interesting part. It says, find and interpret the value of the ratio in part A. We're talking about the value and interpreting that value. Value tells me how much, what it's worth. So if you go back to the 3 forms, which one kind of could tell, gives you a number or one that you can find a worth for? Okay, value, the value of a ratio is going to be the fraction form. You're going to want it to write it as a fraction. Just like up here in the key idea part, or out here where it says value of the ratio, and they have it written as a fraction, that's how we find the value of the ratio, because what does a fraction actually represent? Fraction actually represents what operation? Division. So we're having to divide this ratio out because it can be written as a fraction. We can divide it. So we're going to take the fraction form, 3 halves over 2. And we're actually going to, you can either have a few options here. If you want to plug it into your calculator, you can. And I'm going to pull up the calculator. Okay? But it's tricky. When you have a fraction over a fraction, you have to be very careful when you do your typing into the calculator because it can get a little frustrating. So I know it's got to be a fraction. The top part is going to be a fraction, so I'm going to hit the fraction button again. And I'm going to put my fraction in. And then my denominator is not a fraction, it's just a whole number, so I can just put 2. And then it's going to divide it out for me, and I get 3/4, which is totally fine. Or, if you prefer, you can take the 3 halves over 2. You can know that a fraction represents division, so you could type it in as 3 halves divided by 2 gives me 3/4. So that's the value. But our question also wants us to interpret the value. What does interpret means? Tell me what it means. What does it represent? Well, what did the top of our fraction represent? The top of our fraction represented cold water, right? And the bottom of our fraction represented glue. Well, that stays consistent, that stays the same. This 3 still represents cold water, and this 4 still represents glue. But what it's representing is the whole of it. If you go back here and look at the measurements, okay, it's being measured in cups and teaspoons, right? Well, what it's saying is, initially it's 3 halves. That's not a whole. What it's saying, what it's meaning is that if you're going to do this, if you have 3 whole cups, whole being the key word here, 3 whole cups of cold water, then you need 4 whole, whatever the measurement was, teaspoons of glue. So we're talking that's giving that value there. So that 3 is 3 holes, and that 4 is 4 holes set up as a ratio. You could almost rewrite it as this. Okay? And they're all going to be equivalent. They're all going to be the same thing. And we're going to talk about equivalent ratios later on. but this is the value. The value is 3/4, meaning that 3 whole cups of cold water and 4 whole cups of glue is what is needed. Okay? All right. Does that make sense? Kind of? Clear as mud, maybe? Okay, we're going to practice more of that. But just know, value talks about a number, and which one of these forms gives me a number? The fraction gives me a number. The word can't give me a number. A colon can't give me a number, but a fraction can give me a number. Okay, and that when we solve for that, we end up getting how many wholes we would need of something. Okay, so let's try another example of that. It says you mix 2/3 teaspoons of baking soda with 3 teaspoons of salt. Find and interpret the value, there's that value word again, of the ratio of baking soda to salt. Remember, order is really important to remember. So if they want baking soda first, then we've got to put baking soda first. Okay? So interpret the value means it's going to want it in a fraction form. So I'm going to know I'm going to put it in a fraction form. And I've got baking soda on top, and I've got salt on the bottom. So I've got 2/3 of baking soda to 3 teaspoons of salt. And I'm going to find the value. I can either punch it in my calculator right here. Remember, I'm starting out as a fraction. I've got a fraction in the numerator, so I need another fraction. I've got 2/3. Make sure you're typing this in the calculator with me. Everybody got that? Over 3. I'm going to hit enter, and it gives me 2/9. Or, like I said, if you prefer to write it as a division problem, you can do that too, where you've got 2/3 divided by 3 equals 9. Not 9, sorry. Equals 2/9. Okay, so our value overall is 2/9. Okay, that's great, but what does that mean? What does that represent? Okay, I want you to take 30 seconds, turn and talk to your neighbor and tell your neighbor what you think or interpret 2/9 and what this means about that ratio. Go. All right, beautiful, beautiful, beautiful. Okay, so let's see what it represents, okay? So let's see if we agree. So I've got 2, and my notes back here says it represents whole. The 2 represents, going back to my fractions, represents baking soda, and I had teaspoons. So I'm going to say it represents 2 whole teaspoons of baking soda. So if I am adding 2 whole teaspoons of baking soda, then to keep the recipe the same, to make sure that it turns out like it's supposed to, like my biscuits or something, if I want my biscuits to turn out right, if I'm going to put 2 whole teaspoons of baking soda, then I have to put 9 whole teaspoons of salt. That's what that means. That's what the value means. Is that what you and your partner talked about? Hopefully so. Okay? All right, good deal. All right, so we got another one just like it. Okay, it says you include 1/2 teaspoon of essential oils in a solution for every 12 tablespoons of, there's half a tablespoon of essential oils in a solution for every 12 tablespoons of jojoba oil. I don't know how you're going to say that. Find and interpret the value of the ratio. Once again, we're interpreting the value of the ratio of oil to essential oils. Okay, so I want you to take a second and I want you to set it up. How are you going to find the value of this ratio? So find the value. Make sure you're paying attention to the order. They want this jojoba oil first, so that's what needs to go first. because we're talking about the value, you should be setting it up as a fraction. So the J oil goes on top, the E oil goes on bottom. I've got 12 tablespoons on top, and I've got half a tablespoon on bottom. Okay, that's setting up the ratio. That's finding the ratio. Now we want to find the value of the ratio. So you should be typing that into your calculator, or you should be dividing it. And you end up with 24. All right, but Miss Pittman, I got a whole number. We've been getting fractions. That's okay. Can we turn this whole number into a fraction? How do I turn any whole number into a fraction? By putting a 1 under it. That's right. So, what does this mean then? So I'm going to share what does it mean. All right, that's right. You would need 24 whole tablespoons of the jojoba oil. And if you have 24 wholes of that, you're going to need to add 1 whole tablespoon of essential oils. Okay? All right, so that's as far as I think we're going to get, unless there's some extra time and Coach Jones wants to go on to ratio tables, which I think what I want us to do is, instead of going on to ratio tables, let's do, if you turn the page under where it says practice, okay, I want you to do the practice numbers 10 through 13, which is just like this, okay? And then if y'all finish that and you review that and go over all that, and there's still enough time, then y'all can go on to ratio tables. But let's do this first, okay? Awesome.